Good afternoon, everyone, and thank you for joining us. This is a webinar that we're at WhiteSpider is running. It's one in a series of webinars that we are presenting. And this one is all around next generation SD-WAN. So I'm the one of the directors of WhiteSpider, and I've got my colleague Louise, who is the lead on the technical side of the business, and leads WhiteSpider, one of the founders of WhiteSpider. So I'm going to introduce him now, and then we will start the actual presentation. So, Bill.
Great, thanks, Johnny. Johnny, you hear me okay, loud and clear?
Yep.
Oh, good, perfect. All right, so good afternoon, everyone, on a kind of warm and sunny afternoon. As Johnny said, we're just going to spend hopefully around kind of 40-45 minutes just talking you through not just SD-WAN, but how SD-WAN has evolved over the time. It's certainly not a new technology. It's been around since, I think we've been working on SD-WAN since around 2014, something like that. But the way in which the solution has evolved and the way in which we work and how we access applications has evolved. And so, there's a real interest in this right now. So we thought, as part of our technical webinar series, this was a kind of interesting area for people to touch on. As you can appreciate, when I can use a mouse. Technology revolutions are a way of life, certainly in our industry, and how SD-WAN is evolving, how we use applications and how that's evolving. It's certainly nothing new. If you think back, I've been involved in IT now for 20 odd years, nearly 30 years, I think, something like that. You look at the evolutions and revolutions that we've seen, when we looked at the convergence of voice and video, when we looked at the convergence of storage and compute and networking with hyperconvergence. These are all kind of changes that we see in our industry. So there's certainly nothing new about this kind of particular evolution in SD-WAN. But you've got to try and look past what the marketeers are saying. I think anyone that's probably met me before will know that I'm not a fan of marketecture. I like to kind of know the nuts and bolts and see whether technology has a kind of specific purpose or use case, or whether there's a little bit of fluff involved in what's being conveyed. And so with the kind of revolution that we're talking about in terms of SD-WAN, the analysts and the industry have kind of got hold of this as well. And so we're not kind of talking about what they're regarding as the fourth revolution. This is kind of Gartner, a Gartner definition essentially. I can't imagine anyone was around for the earliest part of the industrial revolution, but we're all kind of massively involved in what we're calling the fourth revolution right now. And certainly within our industry, cloud technologies and how they've evolved, how we use them, how our applications are delivered within them, how we get the kind of flexibility and agility of what cloud delivers, but then also how we secure that kind of capability. Cybersecurity is a big thing around what we're doing within the fourth industrial revolution. And for some of you, IoT might be a thing as well, and how we provide access to our IoT devices and how we segment them as well. That's becoming a really kind of interesting way in which we're delivering infrastructure moving forward. And it's certainly a compelling argument for the use of something like SD-WAN. And as we'll kind of go through this presentation, how we can use some of the SASE technologies to deliver security and connectivity within the infrastructure. So I think it's fair to say the way in which we are using applications has evolved massively. We've probably all been involved in data center and application centralization, where we had mainframes and all the applications ran there. All our users were remote from it, and we had thin sessions. And then we went into a more of a distributed based architecture where we were remote, and the applications that we had could be delivered within branches, for example. We're kind of talking around the kind of early days of Windows server technologies, that kind of thing. But you know, we've started to look more. We then started to look more in terms of centralization of applications. So we moved back into the data center, and the DC was the hub of everything that we did. Every application was delivered within there, and that really became a central part of our organization. And how we made that highly available was a big part of what we were delivering through the kind of early 2000s, late 2000s. But because of the evolution in technology, it's allowed us to use applications and connect to applications in a very different way. And you know, cloud is certainly not a new area of what we're doing, but the capability of cloud has evolved massively. And people's aspirations around using cloud, you know, some, you know, well thought out, you know, approaches around moving applications to the cloud. Some have been kind of quick knee-jerk reactions. Let's move everything to the cloud and then have to reverse it back. But essentially, we're giving our users choice now in terms of where we can deliver an application from and how they connect to those applications. And so cloud technologies, whether they be infrastructure as a service, whether they be software as a service, or whether we develop or deliver that cloud capability on-prem, is certainly giving us choice, but it's also, you know, giving us challenges as well. But it's also making us dependent on newer types of infrastructure where previously we might have frowned upon using technologies like the internet to deliver a corporate critical application, for example. Excuse me. So internet connectivity has now become business critical. You know, the way in which we connect to our SaaS environments, you know, whether they be from home, from a branch, from a campus, you know, from any kind of device that we choose, you know, more often than not, a very high percentage of access is going over the internet. And that kind of brings into question the things that we always used to kick around before. You know, in the internet is a contended infrastructure. There's no guarantee of service, no quality of service in the internet predominantly. The internet being a public network, it's open to the risk of cyber compromise. And because of the inability to guarantee a service level within the internet, the quality of user experience was very inconsistent as well. Obviously, where we're delivering different applications in different clouds, we've then got a really interesting degree of complexity around how we provide connectivity to those clouds. So where previously our applications were all in the data center, and it's, you know, a straightforward means of connectivity from a branch site or from a home VPN or something like that to route directly into these applications, we now need to look at providing some means of securing connectivity into, let's say, Azure or into AWS or into you know, a different data center within our same organization. You know, we've got some really quirky kind of constraints that we're working with in order to deliver a consistent experience for everyone. And really that was where the advent of SD-WAN came from. As I said, SD-WAN isn't new, and you know, lots of people are actually using it now. It's a very mature kind of technology, but SD-WAN was born out of these technical challenges around how do I centralize the configuration of all of my WAN infrastructure? How do I guarantee a consistent level of performance for applications and users? How do I guarantee that end user experience? And how do I deliver a standard policy across the board, whether that be in terms of quality of service, in terms of security, in terms of how I route applications? You know, we're kind of moved well away from routing traffic based on just IP routing tables. We're now routing applications based on the criticality of that application. And so what the industry did is the industry responded to that set of constraints and challenges by delivering SD-WAN. So, you know, I don't want to go through this slide line by line, but essentially we're interested in delivering all this functionality here, this capability, the challenges that we saw on the previous slide, and summarizing it around these key capabilities, and then delivering a WAN solution that delivered each one of these capabilities. So circuit load balancing, for example, you know, if we're concerned about the level of service that we get from the internet, you know, even though it's a relatively cheap service, we want to guarantee a level of performance, then why don't we use multiple internet circuits and send the same traffic down a number of different circuits at the same time, so that when it gets to whichever packet arrives at the B end first, we just use that one and we forget the others. That gives us a really responsive means of delivering application performance. because we are predominantly using clouds these days, you know, for things like software as a service, infrastructure as a service, it doesn't make any sense to trombone a branch office traffic down through the data center to go out to the internet to a cloud facility. Customers are interested in having local breakout, having direct internet access. And we also want a consistent means of operating this whole environment. So it doesn't matter if I'm a branch office, a headquarter, a data center, cloud infrastructure. I want to manage the configuration of that centrally and deliver a consistent policy across the board. Now, a lot of what we can do with SD-WAN means that we can actually use lower cost circuits. We don't have to use expensive MPLS anymore, you know, and some people argue MPLS is mainly a kind of dead technology unless you're looking at consuming SD-WAN from, you know, one of the telcos, for example, who all have an SD-WAN offering now. You know, they have to sweat the MPLS assets, so they're delivering their SD-WAN capability on the MPLS infrastructure that they built previously. But separate to that, you can consume any kind of circuit you like from any provider you like and get a consistent performance irrespective of whether you're connecting to your wide area network with, you know, BT, with Verizon, with AT&T, with Singtel or whoever. So and we have choice over circuit costs. And as I said, with internet, we can actually guarantee a level of behavior and performance and user experience by how we do the design around SD-WAN. And multi-cloud, you know, it doesn't matter if you have infrastructure as a service within AWS and you have software as a service within Azure and you have your own private cloud. We can deliver that SD-WAN capability with all of this functionality on the left-hand side by using SD-WAN as a transport mechanism. So essentially, the kind of core capabilities of SD-WAN in its earliest incarnation was all about application aware routing. So we want the ability to be able to look at an application and determine which path I want to send my traffic down. Do I want to use an expensive MPLS circuit, maybe for a time sensitive application or something like that? Or do I want to just use a low cost internet connection for people browsing the internet? We want to be able to provide the ability to manage this centrally as well. So we need some infrastructure where I can describe my intent, so how I want my WAN infrastructure to operate, and then we want that management infrastructure to deliver that intent to a layer of orchestration whereby I push my policy and configuration out to a number of devices that are connecting my branches and HQ and data center and clouds, for example. And we want to do this in a secure manner. Okay, we're all familiar with using VPNs, having multi-site VPNs and dynamic multi-point VPNs. You know, we're using a technology, you know, IPsec VPNs with encryption and authentication as the transport security model within SD-WAN as well. So we're using technologies like, you know, the internet, like 5G, like MPLS, like satellite point-to-point, you know, transports like that, for example. But we're using an encryption protocol to build tunnels across that insecure infrastructure, essentially. So we get that multi-layered security model there, whereby we can provide secure segmentation from the point of ingress at a branch site to the point of application delivery within a data center or cloud. We can optimize the performance of applications by looking at the criticality of it and any constraints that it might have. So, for example, we may have an application that is sensitive to delay, or an application that's sensitive to loss or to delay variation. You know, we call that jitter, and we can determine if my transport goes outside certain constraints. So if the amount of loss that I experience on my internet connection goes above 1%, for example, then I can switch my routing to use a different path. So we have the ability to optimize how applications are delivered, and that's called application aware routing. And we want this to be able to scale into, you know, anywhere within the country, geographically, within any cloud, for example, and have the ability to integrate and automate a lot of how we deliver that capability. So in summary, the kind of core elements of any SD-WAN solution. So at the minute, I've not spoken about any vendor, any particular technology or platform. This is SD-WAN in general. And these core capabilities down the right-hand side are consistent across the board. And it doesn't matter whether we're talking Vela with VMware, obviously, if we're talking about Cisco with Viptela, if we're talking, the Meraki offering, if we're talking about Silver Peak, for example. There's so many different SD-WAN solutions now. I think there's 126 when I looked the other day. But the solution elements are essentially the same. We want an orchestration plane. This is something that we use to onboard a device so that we can take a device. We don't even need to touch that device. We can send it to a customer site and we plug that into the internet. It does DHCP, it gets an IP address, and it immediately goes out to my orchestration plane to say, here I am, what's my identity, what do you want to do with me? And that gives you what we call zero-touch provisioning, ZTP, or if you're American, ZTP. But zero-touch provisioning allows us to send devices out, not have to touch it, and that device is immediately added to a WAN fabric in a relatively seamless way. We have the management plane, and it's the management plane where we describe our intent. So we say we want to have routing based on, this criteria, for example. We want security to follow this particular model. We want monitoring and analytics to take place, looking at these kind of traffic types on these types of connections that we have. And then we have the control plane that then delivers that intent. Okay, so the control plane is saying, I need the routing to behave in a certain way. So I'm going to send the routing topology to the devices that exist within the data plane, and the data plane are just typically the routers that you all have within your wide area infrastructure. If it's a Cisco router, the Cisco router can be run as a traditional router with normal routing protocols, BGP or SPF, for example, or you can deliver that router with an SD-WAN feature set. Where it's acting in an SD-WAN capacity, the device is solely concerned with moving data from interface to interface, from A to B, based on a routing process that is controlled by our control plane. Okay, so these are the consistent and common attributes that allow us to deliver an SD-WAN capability. And we call it the power of abstraction because we're taking all these away. If you think about a traditional router, its orchestration, management, and control plane, the data plane all exist within the CLI of that device. Okay, how I onboard my traditional router, I give it a configuration, I pre-configure it, that kind of thing. How I make changes to it, I either use a browser or I use a CLI. The control plane is all done when you configure, router BGP or router OSPF, and the data plane is the actual forward information base, the RIBs and the FIBs that you have within those devices. Okay, so the power of abstraction takes that capability away and it makes the solution far more scalable. So the real kind of benefits really of using SD-WAN architecture, if you think about it in terms of how you can deploy this, we essentially can deploy any service that we have. And any application that we have on using any service integration. So whether it's cloud security, whether we want to look at voice and video integration, whether we want to extend it to the cloud, we can put it onto any transport we want. As I said, satellite, internet, MPLS, LG, 5G, LTE, 4G, for example, and I can provide that capability at literally any location. So whether that be a large data center that used to be our hub, in modern application distribution now, the hub has moved away from it being the data center, so it now being the user. We're now the hub. That's where the service is delivered, whether we're connecting to it remotely or whether we're providing services, remotely or providing the service to us on-prem. We can deliver this SD-WAN capability. And we can actually deliver this functionality where we put all the abstracted parts either in a cloud, so we can deliver our SD-WAN management, orchestration and control planes within a public cloud, or we can deliver our management, control plane and orchestration on premise. The choice is ours entirely. And we can manage all this in an open, programmable, API-based way. So we can say, instead of clicking around a GUI, we can just actually send a script to a device that changes the security policy across the board of our SD-WAN infrastructure. And that's quite an interesting capability to have. If my application policy changes, if I introduce a new application and it has certain constraints around delay and loss and jitter, if it has constraints around connectivity, it has constraints around security and segmentation, I can describe that intent within the management plane and push it out to 1,000 devices, in a few seconds. And this is, the real big game changer from an SD-WAN perspective. So if you just kind of focus in on what the kind of key benefits, were and are from an SD-WAN, conscious that, still people are yet to adopt SD-WAN, is certainly around the predictable application experience, irrespective of transport. Okay, so in the early days of delivering SD-WAN, people wanted to do SD-WAN, but they wanted to connect it to their MPLS environment. They still didn't trust the internet. Okay, now over time, over the last few years, more and more organizations have kind of moved away from saying, well, right, our data center needs to have 2 MPLS connections, and that's what it will have from a transport perspective. Now we're actually finding environments where let's just have 1 MPLS connection and 1 internet connection, because we can actually route some of our traffic across the internet, for example, and some of it we still want to use the investment that we've made in MPLS. We're not quite at the time where the MPLS contract is up for renewal. And that's the same from a branch perspective as well. People might have a single MPLS that they had at the branch site that have now evolved and moved on to you, maybe using 1, 2, 3, 4 DSL based internet connections, for example, and still getting either the same or better experience. Obviously, bandwidth from an internet perspective is a lot cheaper than bandwidth from an MPLS perspective. So we're adding more bandwidth. We're providing a better level of service across that. So predictability and end user experience is a big one. Having the right security in the right place. So, being able to provide the capability to segment your infrastructure is a massive driver right now. And we're working with some retail organizations where their insurers have said to them, because of things like ransomware, we want you to demonstrate how you are segmenting your wide area network and your local area network, so that if I'm a guest, I'm not just routed generically across the same routing process as a corporate user, for example. And so having the ability to segment, which as a techie, I can tell you can segment using more classical approaches. There's things like VRFs, for example, that we can segment with. But MPLS, but SD-WAN gives us the ability to provide segmentation that is centrally managed. So I can say I've got my third-party segment, I've got my contractor segment, I've got my corporate segment, and I've got my guest segment. And I can actually manipulate that and how the routing of those segments behaves across an entire infrastructure. And we provide that using encryption. So, we've got the ability to satisfy the regulatory requirements of, large insurers that are protecting the interests of, retail organizations, for example. And obviously we can provide an intent-based capability where, as I've said a couple of times, we describe the intent, we describe the security model, we describe the routing policy model, we describe our integration with security services, and we push that all down and we deliver it in a very seamless manner. If I want to provide an upgrade across 100 devices, I can just upgrade 1 device, 10 devices, 50 devices. I can put them into upgrade groups, but I can actually make sure that the security posture of my wide area network is far tighter than you ever could do with a traditional environment. If you had 100 sites previously, you were upgrading 100 devices one by one. In an SD-WAN environment, you can do the lot or you can do it one by one, and you decide. It puts the control back in the hands of the operations team regarding how you make configuration changes, how you operate and maintain that environment. And ultimately, it's a single interface that delivers the routing capability, and it delivers the connectivity, and it includes the security side of things. Okay, but in its earliest incarnation, the security was very much around how do I protect my traffic, i.e. encryption, how do I prove who I am through authentication of VPN connections, and how do I segment? So we can actually do that by having separate VPNs, but it still wasn't addressing some of the more kind of pressing concerns around things like direct internet access. If I've got an internet connection at a branch site, surely I want to be able to use that connection to allow my users to go out to the web. If they're browsing LinkedIn or Facebook or just, anything like that, or accessing SaaS applications, I don't want to trombone them through the data center. That's an inefficient use of bandwidth. I want to be able to allow them to break out locally. And so that's always been a concern. How do we allow that to happen while still maintaining a degree of centrally managed security? You know, I want my security policy to extend to the edge of the network and not just within the data center. Okay, so these are the kind of key 3 pillars that we have from an SD-WAN perspective. But the more you talk and the more you work with customers, it comes down to the dollar, right? So, you know, how much is SD-WAN actually saving me and what's the kind of benefit I'm getting from it? So these are kind of based on, you know, real world figures taken from a real world use case and customer solution that we've designed. So if you think MPLS, as I said, I can't imagine many people renewing on MPLS right now. You know, the capabilities are better elsewhere. But if you think a 10 meg MPLS connection, generally about $1,800 a month, you know, when you start to trust the capability of SD-WAN, you can potentially drop that down if you still have an investment in MPLS, but you can add a 50 meg broadband and you're already reducing a lot of that kind of capital spend whilst actually benefiting from a high level of throughput, you know, via the internet side of things. The further you go down this is, you know, you can actually have 2 50 meg connections here. Now, the beauty about this is, from a quality of service perspective, if I have traffic going into one of these connections and you're really not sure about the level of performance or it's really critical, you can send packet ABC into broadband 1 and you can also send packet ABC into broadband 2. Whether A gets to this end first, to broadband A first, and B gets to broadband B first, the packets are reorganized at the end so that, you know, you can send multiple flows of the same traffic and it's reconstructed at the end. So you never actually get any loss like that. You can obviously add another 50 meg broadband or 100 meg broadband. You know, if you look at kind of Virgin now, they're up around the kind of gig mark, but you can add any number of connections up to here. Say any number, you know, generally never really seen more than 6 connected to a device. But you can do either equal cost multipath load balancing down these connections, or you can put the same traffic down each of them and really guarantee a level of service. But essentially, by having more trust and actually relying on how you design and create the intent of the infrastructure, you can save, you know, roughly around 90% in WAN costs just around this particular use case here, which is a real world kind of use case. And so where does this kind of approach, this solution framework, where does it, you know, fit in terms of sectors? So, you know, we've delivered SD-WAN, you know, certainly within these and more. Hospitality is another area we've delivered SD-WAN, but it has a large scale applicability to all segments that have a wide area network. You know, there's the odd use case here and there where, for example, we worked with one customer and literally every application they had sat within Azure, and that's literally all they had. It was all just sat in Azure and it was all connected to via SSL. That's not a use case for SD-WAN predominantly, because literally everything just went out of the internet connection and it was all SSL protected and nothing else was part of their application estate. However, 99 other use cases are fit for purpose, and as I said, we've delivered SD-WAN across all of these, delivering, you know, large scale capability whereby, you know, one organization wanted a geographical WAN, so an SD-WAN in Asia Pacific, an SD-WAN in North America, an SD-WAN in South America, an SD-WAN in EMEA, and then have a backbone that connected all of these SD-WAN environments together. So from a management and orchestration perspective, each different region wanted management autonomy of their own SD-WAN environment, but they still wanted to connect over an SD-WAN overlay. In that regard, we just build VPNs across the different SD-WANs and we create a backbone mesh, for example. But hugely scalable infrastructure and environment. But as I said previously, it was always and has always been limited by the constraints that we've had around security and how organizations have said our security model is to provide all of the protection within the data center, our URL inspection, our DNS security, our anti-malware, our firewalling, our IPS. That's where we're doing it. Okay, so we're not going to allow local breakout at the branch, irrespective of whether that person in a branch is connecting to a cloud-based SaaS service. So this really was the evolution of SASE, Secure Access Service Edge. Okay. The interesting thing about SASE is that, you know, the actual framework around this came from one of the analysts from Gartner. You know, they first realized that there was an increasing demand to provide security that we have in the data center at any point within our ecosystem. So the edge was wherever the user was accessing an application. So whether I be a remote access user, whether I be sat in a branch, whether I be sat in a DC or in a HQ, we want the same security capability across the board, irrespective of connectivity capabilities, if you like. So obviously the key reason for doing this has certainly been the cloud revolution and how we access applications. You know, we talk about hybrid clouds, we talk about hybrid work. I think, you know, the whole hybrid work thing has certainly become a massive requirement since the pandemic. But there was certainly a large driver around SASE well in advance of people going into lockdown and having to access applications. You know, but you know, during the pandemic, there was certainly a massive uptick in terms of providing that security capability for remote workers as well as remote branches. Okay, so cloud applications exploded. You know, we see organizations, whether they be using SaaS applications like, I don't know, 365 or something like that. Salesforce, you know, is another one, but also privately developed applications that reside within a public environment where our users need to connect to. And as I said, these users might be connecting at a branch office. The users might be connecting from a campus. The users might be connecting from home. Okay. So branch security, depending on the organization, has always been a difficult area for most people. You know, people have wanted standardized security models, and in the whole, that's reasonably achievable. You know, if you have an internet connection, let's say that you do a VPN over, you just don't allow local breakout. The VPN is purely for a WAN transport. Even though there's connectivity there, we wanted to always bring people through the data center to make sure that all of our inspection carried out at that point there. Where there were mergers and acquisitions, different organizations handle security differently. So some organizations might have next generation firewalling and intrusion prevention at a branch, and some might have nothing at all and just allow local breakout. So there was a real kind of disparity between how different organizations were providing branch security, and it then became very difficult to manage as well. So if you were distributing firewalls around, you needed something to make sure that the policy across all these firewalls at different touch points within the infrastructure were all consistently managed. And obviously, we've spoken about the remote workers. You know, these people, you know, the hybrid working kind of approach really put a stress on the network. And certainly when we went into the pandemic, there was a real stress around things like VPN performance. You know, we have license for concurrency of 100 users. Now, all of a sudden, we've got 10,000 remote workers, for example. We've got internet connections that are sized to allow concurrency of 100 people, because our policy says no one's allowed to connect directly to a cloud application. They have to come into an internal proxy first and then out to the internet. And the internet performance was throbbing. So the requirements around remote workers are certainly made us look at and evolve how we deliver that capability across the board, whilst, you know, hopefully improving the overall user experience, essentially. And for those people that like statistics, you know, this is a Gartner statistic. I think everybody likes to reference Gartner, don't they? But certainly from a SASE perspective, you know, these really are the authorities on the initiative in its earliest days. 45% of businesses respondents cited reliable network performance as the #1 challenge for hybrid work adoption. And that's not just a kind of tainted analyst statistic. That's generally what we've seen in the past as well. You know, you can move people to work remotely, but whilst ever your mindset and policy around security is very much set around the data center being the hub, network performance is definitely going to be affected by that. Okay. So this was realized, you know, very early on, and certainly SD-WAN was a key driver into looking at how we evolve the security model moving forward. And so there was this realization, as I said, you know, the realization, not just from Gartner, but Gartner were the first kind of organization to put a framework around it, whereby we were going through another area of convergence. You know, as I said early on, we had the voice and video and integrated data convergence piece, you know, back in the In the early 2000s, we had the storage, compute, and network convergence piece around hyper-converged infrastructure, around kind of 8-10 years ago, something like that. We now have this convergence whereby we have the means of connecting to any application from anywhere on any transport for any use case. However, we want to make sure that that capability is as secure as possible. So we've got the security side of the requirement, and we've got the connectivity side of the requirement. And the merging of the two is what came to develop SASE, the Secure Access Service Edge. So we have the ability to now to deliver. When we say network security here, we're not just talking about ACLs, we're not talking about layer 4 inspection, we're talking about NGFW capability here, whereby we're talking layer 7 application inspection for firewalling. We're talking about cloud access security brokers as well. So we're actually providing a firewall capability out in a cloud that gives us the same, if not better, security capabilities as we had with data center centralized firewalling. So when we start to look at how SASE has evolved, and again, lots of vendors have approached it differently. The model I'm going to be talking through here is how Cisco have approached the whole SASE framework, is the ability to converge their SD-WAN capabilities. So if you think, Cisco have two offerings. They've got the acquisition that they made with Viptela, 2017, I think it was. And they've also got the Meraki capability as well. But essentially, we're providing this wide area network that allows us to have a secure, scalable, centrally managed connectivity model that provides application sensitive performance. And it's dynamic in how it responds to the changes in network conditions. So if 1 minute my connection on one transport is working perfectly, I'm getting 3 milliseconds delay and I'm getting 0% packet loss, and all of a sudden that changes, it has the ability to dynamically change the path that an application takes based on the policy that you define. So that's the software defined WAN connectivity side of it. But as we've already said, if we're providing this capability at the branch level, we want the ability to provide enhanced security at the branch level as well. So we can actually use local breakout or direct internet access. So where we have a branch, we don't really want to route traffic that's going to the internet all the way over my wide area network transport through the data center environment, through a data center local data center breakout. What I want to be able to do is look at an application or look at a traffic flow and say, what's the destination for this? And where is the most appropriate transport to send it on? Is it most appropriate to send it out of the internet? Is it most appropriate to send it via the data center? And that's the integration that we have with the SASE security capability. So I can provide DNS layer security, and I can either provide this as agent-based or agentless. I can provide it with a touchless configuration whereby there is a transparent proxy within the branch that says any traffic at all, go to my proxy, and that proxy is something that then exists within the cloud. So if you're going to Cisco.com, for example, the DNS lookup for Cisco.com goes to a DNS layer security capability in the cloud, which would be Umbrella in Cisco's case, and it then tells you whether that is an appropriate URL to connect to, and it will give you the IP address to connect there. These are all very low latency capabilities. I can provide either a proxy-based cloud firewall or a proxyless based firewall. So I can either tell my browser to go to a proxy in the cloud, or I can do it transparently. The routed gateway at the branch site intercepts all of my traffic, and it said if it's going to this address and it's web-based, go to the cloud delivered firewall. If it's not, then go across the SD-WAN infrastructure to the data center. And all these capabilities here, as I said, the guys that understand Umbrella will recognize that these are Umbrella-based capabilities, something that we call SIG, Secure Internet Gateway, essentially. All cloud delivered, all can be connected to either transparently or via a VPN-based connection. But we're also looking at how do we protect the identity of individuals that are connecting to our applications at the branch as well, and connecting to applications that run within the cloud. So zero trust is certainly not a new kind of capability, but we want to integrate this into the overall solution. So where we're providing remote-based access for users where they're a hub of one, an office of one, for example, sat at home on a VPN, we need to make sure that we have who they are, or what they're allowed to connect to, when they're allowed to connect, what device they're allowed to connect from. And provide things like multi-factor authentication via a central capability. So, this kind of capability, in Cisco world would be Duo, but, there's Okta and there's other solutions like this that provide an identity-based capability as well. We also want to look at, okay, we trust someone and where they're going, and we've got a connectivity, means that it's secure, but we want to look at how well that capability is being delivered. So we want to continually monitor how application performance has been delivered to our users, what the remote user experience is actually like. We want to look at the paths that we're taking. And remember, I said that, if we have one preferred path and that path suddenly is affected by congestion, I need to be able to make a dynamic decision around changing what path I take. So with the ability to actually look at the WAN health, look at the path that I'm actually taking, and make agile decisions around maintaining that application performance. So visibility into not just the control side of what SD-WAN is delivering, but also the application performance and the user experience of how we're delivering it gives us insights into what action we need to take next. Excuse me. And then finally, where we have remote users and we want the remote user to connect to applications in a secure manner, we have the ability to provide them with an agent, and that agent needs to, again, ensure that we've got visibility over the applications they're connecting to, that level of performance, and also provide us with granular security as well. So, we're talking in the Cisco world here. If you're familiar with AnyConnect is now rebranded as Cisco Secure Agent, and that's part of the whole SASE ecosystem. So that agent is delivered to a mobile device that then provides you with a secure connection, and it then gives the visibility, compliance and security to enhance the overall SASE capability for users connecting to cloud-based applications. So if we were to kind of glue all this together, what does this look like from an architecture perspective? And so we have the network side of what SD-WAN provided us with originally. Okay, so where am I? I have a branch user, whether I'm a remote worker or something like that. I connect to these either VPN-less, so I can connect into my infrastructure using a browser, for example, or I can connect using an agent-based VPN. And we saw the Cisco Secure Agent on the previous slide. Where I have a branch, I can connect traditionally via the network, and I can also access enhanced security capabilities that deliver that cloud-based security capability. So I can provide things like NGFW in the cloud. I can look at a file that's actually being downloaded by a user here and use the Talos cloud to determine its reputation, to see whether that is something that presents risk. Ultimately, it gives us end-to-end visibility. It allows us to look at how we're connecting, what we're connecting to, the experience that we're having from the users when they're connecting to the applications, essentially, and from any point, any device, any place, any transport. So if we look at this again, just from two use cases, one being the secure branch connectivity. Secure branch, I can either connect local breakout going out directly to an internet SaaS cloud. Okay, so this is where I potentially trust that traffic. It's an SSL connection, and I'm happy with that connection going out. If I then want to access public applications, I can use something called Auto VPN that connects me into the Cisco SASE cloud. So these elements here, as we said, would be provided by the umbrella cloud. These here are additional capabilities such as Duo and such as ICE, for example, that allow us to, authenticate who someone is, but also determine what it is that they're allowed to connect to. So these are all delivered from within the cloud. We then have a device that then makes a decision to say, well, right, based on the security outcome of the inspection here, I'm either going to send that over the internet in an unencrypted manner, or I'm going to send it to a private application that might exist within Azure, AWS, or something like that. or I might connect directly into my data center or to a branch. So this is the more traditional SD-WAN overlay that we've had previously. And so from an SD-WAN perspective, we would have an SD-WAN gateway sat in a branch here, and we could have an SD-WAN gateway sat within the cloud. You know, you deliver these by going onto the marketplace of AWS or marketplace of Azure, and you just create a virtual SD-WAN gateway device, and that just becomes part of your overall SD-WAN infrastructure. So if I'm a remote worker now, so I'm connecting from home, so I'm using the Cisco Secure Agent client that resides on my Mac or laptop, Windows laptop, for example, I can launch an IPsec connection, TLS connection, whichever, into the secure cloud. I can have all my application traffic inspected by the cloud in the same manner as was on the previous slide. So we've now got consistency of security capability, whether I'm in a branch office, a data center, or a remote user. The other option is if you have guests that want to connect to your application and they don't want to install the secure agent, you can use a browser-based session. So a browser-based session is actually sent to the VPN proxy that is Umbrella, and that then gives you the ability to either break out via the gateway that exists within the Umbrella cloud to private applications. Maybe you're a guest and you're accessing something that they have. That's the means of connection there. Or if they're providing that via the internet, in a public manner, you would actually just go through that cloud there and break out direct to the internet. So depending on the security policy there. Again, if you're an unmanaged endpoint, you're using a browser session, we can even connect on-prem over the SD-WAN gateway using a breakout that is encrypted and part of the SD-WAN fabric as well. Okay. So those really, that branch connectivity and that remote worker connectivity are the two use cases that we see most consistently across the board. So as you can imagine, looking at this here, and there's lots of different things. So if you're, if you already have Cisco infrastructure, if I look at this one here, let's take this one as an example. I've got Umbrella-based licensing I need to kind of look into here. I've got Duo-based licensing I need to look into here. I've got ICE-based licensing. I've got SD-WAN licensing, and how the licensing is provided depends on the functionality that you want. But it can be a little bit of a kind of a minefield in terms of the licensing model that you need to subscribe to in order to deliver this capability. So how this has been addressed is through something called Secure Connect. So this is a subscription model-based approach to delivering all of that SASE capability just with a single license, essentially. Okay, so you can see there are two models here. There's Essentials. Essential gives you all this capability here, so the remote access-based capability. You've got the security bits from Umbrella. So, for example, the web gateway, which is a proxy, URL inspection, things like that, and AMP. And on the Advantage side, this is more around data protection and advanced policy. So, essentially, we're doing the Layer 7 cloud delivered firewall, IPS, DLP, for example. So two different license models. But rather than licensing SD-WAN and Umbrella and Duo and things like that, essentially all we do now is we just determine what subscription plan we want. So how many users want Essentials, how many users want Advantage, determine the volume of people that are part of that ecosystem that we're trying to deliver SASE for, and that's the license model that you have. It takes the whole kind of complex headache out of it, essentially. So that kind of SASE in a nutshell. Conscious we're just getting above 45 minutes. I'll just very quickly, no one gets away from a WhiteSpider webinar without at least kind of 2 or 3 slides just talking about who we are. Generally, the first question we get is, why WhiteSpider? Where's the name come from? And contrary to a lot of kind of answers that we get, the WhiteSpider is the name of an ice field on the north face of the Eiger. It comes from our kind of heritage around mountaineering, essentially. But it epitomizes what we feel are our core values. So, we have a very kind of clear and well-defined set of core beliefs and values, if you like. And when the business was first set up, it was key that we were viewed as a kind of trusted a technology partner. It was less around a kind of sales-centric approach. It's more around how do we become trusted to deliver an open and agnostic opinion on whether technology is the right fit or not. And that's how we built the business around. We want to be want to buck the trend, essentially. We want to be a morally sound organization that is trusted to deliver unbiased and sound advice. If an investment in technology is needed, we will tell you. If the infrastructure that you've got is fit for purpose and we can actually just reconfigure it to make it work better, we will tell you that as well. So trust is the kind of thought foundation that we built the business on. And obviously, if you're attempting the north face of the Eiger with a climbing partner, clearly there needs to be a degree of trust there. Our approach has always been around delivering kind of customer value, about an outcome-based approach, and making sure that how we're delivering our service is exactly what a customer is expecting. We have a very clear consultative approach about all of our engagements, and we have we could tell you how that looks from every single deployment, because it never changes, and it's a tried and tested and trusted methodology that we feel delivers the best value from all of our engagements. And again, from a north face of the Eiger perspective, the approach that you take to get with the north face is definitely going to influence whether you're successful or whether you take a large swing. And expertise, we are built on technical foundations. We've been doing software defined infrastructure now for 10 years. We were probably one of the first in the UK to start to look at what the capability of open networking presented, and we were certainly the first in the UK to start delivering software defined data center infrastructure way back in 2012, 2013, where we were delivering it at a global scale at that point, because it was quite a unique area of IT. So everyone that we have is an SME, a subject matter expert in the domain of software defined infrastructure. And I think we're tenacious. We take on challenges that a lot of people have turned down. We like looking at IT and how we can get the most from it. We like looking at customer problems to determine how we best approach that and how we can deliver the best outcome. We kind of stick with challenges and opportunities to make sure that we get the right outcome, essentially. Ultimately, from a technologist perspective, we like a challenge. Okay, we like using technology to fix some of the most awkward and quirky business problems that our customers have. And I would say, over the kind of 10 years that we've been delivering this, the more quirky solutions are the ones that we've had the kind of greatest sense of achievement from, where, we've moved large scale data centers, geographically thousands of miles, without losing an application or losing a packet of data in real time, for example. A challenge that, some of the largest integrators, in the industry kind of turned down, and we thought, that's something that is achievable, but, the approach has got to be right. Ultimately, we love a challenge. We also are very passionate about technology as well. We're all technologists at heart. We like to see how we can use technology to do more. And, that's why SD-WAN was interesting. That's why what SASE presents is interesting. And, we don't sit back on our laurels and think, right, we're at the kind of point of satisfaction now. We're constantly looking at how we can evolve technology to deliver better and more performance and meet more outcomes ultimately. Excuse me. So from a value perspective, obviously, you can see the marketeers have been all over this one. We are always innovating. We've got in our lab facilities, we've got around about 1.5 million of lab kit. So customers come to us with requirements. Do you think there's a way in which we can deliver this? We'll send the guys in the lab, go and build that out, go and replicate that. And we can replicate most things in the lab. We've got ACI fabrics, we've got SD-WAN environments, we've got SDA environments, we've got compute storage, hyperconvergence, we've got everything in there. For a customer to come to us and say, we've got this challenge, do you think you can do something with that? We are industry leading software defined. As I said, we've done this before people were even thought software defined was going to be a big thing. We were delivering software defined data centers, for example, and we've won awards for actually delivering it as well. We've been awarded by Cisco for delivering it. We've been nominated for delivering similar functionality with VMware, for example. And one of the key principles behind what we do is what we call applied architecture. Anyone that's ever worked in the realms of enterprise architecture will know that there's two things that happen. You work with an enterprise architect that delivers a pile of documentation that's 6 inches thick that doesn't actually tell you, how you're going to deliver it, or you work with the integrators who will great kind of tactical fingers and say, you really need to look at ACI for this, or you need to look at NSXT for that. But in terms of the longer term strategy and standardization, for example, that's less of a focus. What we deliver is an applied architecture approach. We bridge that delivery gap. We're looking at how architecture can be delivered in a consistent manner, and we design and we deliver and we train people on it, and we actually manage and operate it on people's behalf as well. And the final point there really is that we want to be trusted and ethical in everything that we do. We don't have a sales-based approach around what we do. We have a technology-focused approach around what we do. If we don't think we're specialists in a particular area, we will say that's probably someone else's bag. We are specialists in the realms of SDDC, in SDA, SDN across the WAN. Those are where we've made a reputation and where we have considerable experience, and that's where we don't kind of dilute our approach. So very quickly, what business challenges do we encounter? These are kind of 4 key areas that we generally have conversations about, where we do blue sky thinking. We are whiteboarding in front of customers to address some of these kind of business challenges. And the technology comes secondary. Let's understand at its very core, what's the challenge that we're trying to fix here, and then let's see where IT can be brought in to deliver an outcome to that particular challenge. Core services, as I've said, discover, design, transform, migrate, manage. Architecture is a key part of what we do, but architecture sat on its own delivers nothing for anyone. What we like to do is define an architecture, discover how we're going to deliver that architecture, design something to fulfill that architectural vision, transform the environment that we're working in, migrate someone onto a production environment, and then manage the overall environment once it's gone live. These are the kind of 5 core pillars of how we work with our customers, essentially. And as you probably imagine, I've said it a few times, we work in a number of different areas here: hybrid cloud, data center, enterprise networking, and security, with a kind of real core focus around software defined capability. So so that's it. That's everything I have to go through as part of this webinar, just coming up to the hour. But thank you for sticking with it. I do get accused of talking very quickly, and I'm a passionate technologist. I do kind of enjoy talking to customers about technology and how it would fit, specific use cases and challenges. If anyone would like a deeper dive, a whiteboard session, if anyone would like to see what SASE looks like in the flesh, or SD-WAN in the flesh, then please just reach out. I don't hide behind proxies from an email address. Just reach out to me directly, and more than happy to set up a follow-up call, or set up a whiteboard session, or even show you the technology. But thank you very much for listening. I hope it's been useful, and as I said, if you need any other information, then please feel free to reach out. But thank you all very much.
Yes, thank you, Phil, for that. And as he says, appreciate you sticking with us to the end, those who have done. And we will be in touch anyhow, just to follow up if you've got any questions. But we'll also include Phil's email contacts on that, so you can contact him directly, or any of us in the team. And yeah, hopefully speak to some of you directly at some point. Thank you for your time.